All right, let's continue with the back page of this review worksheet over differential equations. Number 3, it says the rate of temperature decrease for a cup of coffee is given by the equation dy over dt equals ky, with t measured in minutes. The initial temperature is 190 degrees Fahrenheit, and the temperature decreases to 76 degrees after 5 minutes. Find the particular equation. So let's create our ordered pair and identify the independent and dependent variable. We know that time is the independent variable and temperature is the dependent, t representing time and y representing temperature. Okay. So we can identify some ordered pairs here. We know that initially at time 0 minutes, the temperature is 190 degrees Fahrenheit. And we also know that after 5 minutes, temperature is going to decrease to 76 degrees. So we have these two pieces of information, and we've seen from before how we can use one to solve for C, we can use the other to solve for K, and that will help us identify our particular solution. But first we need to separate the variables and actually solve our differential equation. So y is on the left, everything else on the right. We see this is going to be natural log of the absolute value of y is equal to kt plus c. Y is equal to e to the kt times e to the c. So this is end up being the equation that we're used to seeing with exponential growth and decay. Y equals c e to the kt. So if I want to find my initial, if I want to find my c value, plug 190 in for y, plug 0 in for t. K times 0 is 0, e to the 0 is 1, so we see that c is equal to 190, so we are making progress with our differential equation solving for it. So now we can use the other order pair to solve for k. 76 plugs in for y, 5 plugs in for t, so we get 76 equals 190 e to the 5k. We want to eventually bring the 5k down, but we first want to isolate this e to the 5k first. So let's divide both sides by 190, and that reduces to be 2/5. Next, we have to use natural logs in order for us to bring the 5k down, so we can use the log properties. So take the natural log of both sides. This right side becomes 5k. Divide both sides by 5, and we get our k value, which is 1/5, natural log of 2/5. So now we have arrived at our particular solution. Okay, part B, find how long it will take for the temperature to decrease to 50 degrees. So let's create our ordered pair again. We know that after a certain amount of time, the temperature will decrease to 50 degrees. So we're looking for a particular t value given a y value, given a specific temperature. So we can plug this into our particular solution and solve for t. So 50 plugs in for y is equal to 190 e to the 1/5 natural log of 2/5 t. Divide both sides by 190, and that reduces to be 5/19. Okay. This t is still sitting up as an exponent, so we need to take the natural log of both sides. So we do that, natural log of both sides. This all this comes down in front, so we get 1/5 natural log of 2/5 times t is equal to ln of 5/19. So this is all just going to be one number, right? So to solve for t, we simply just divide all this to the other side. Plug in your calculator, you'll get 7.285. So it'll take a little more than 7 minutes for the temperature to decrease to 50 degrees. Okay, part C, find the average temperature of the coffee in the first 10 minutes. So average temperature, remember this is using average value theorem. So average value theorem is we take the temperature formula that we just found from part A, and we find the accumulation of all the temperatures and then divided by 10 minus 0. So we simply just plug in our formula, 1 over b minus a, from a to b of our function here. And all this can go in your calculator. Okay, 870 divided by 10, so average temperature will be 87.09 degrees Fahrenheit. Okay. Going a little bit out of order here, around out of space, so I'm putting part E right here. So part E says find the limit of y of t as t approaches infinity. So we basically just have to look at our equation and basically see what's going to happen to this expression when t keeps increasing. Okay. So when t keeps increasing, that means this t will go to infinity. But this coefficient here will be a negative because this is natural log of 0.4. Natural log of 0.4, or 2/5 is 0.4. We know natural log of 0.4 is less than 1. Natural log of 1 is at 0. Anything above natural log of 1 will be a positive value. Any natural log value between 0 and 1 will be negative. So think of this as just one big negative coefficient. So negative times infinity will be negative infinity. So really, this is e to the negative infinity, which is essentially going to be e to the infinity in the denominator. And if you have 190 over an infinitely large number, then this expression will go to 0. Okay, part D. Using 4 equal intervals of right-handed Riemann sum, find the average temperature of the coffee in the first 10 minutes. So we are taking, we need to find the width. We need to find 4 equal intervals. So width is b minus a over n. So 10 minus 0 over 4, so 2.5. So we start at 0, and we keep incrementing by 2.5, and those will be our x values that we'll be using. Okay. So for the first rectangle, we'll use 2.5 to plug into the function. For the second rectangle, we'll use 2.5 to plug into the function as well. 5 to plug into the function, and then plug in 7.5, and then plug in 10. So we're just adding these 4 rectangles. Okay. So the first rectangle has a width of 2.5. The y value, the height will be whatever plugging 2.5 into the function will give us. And y of 5 will be the y value of our function. And then here, the y value at 7.5 and the y value at 10. So all this can be plugged in the calculator. And the width is all the same, so we can factor out the 2.5 if we want. And if we add up all the y values at those at these specific x values, we're going to get 274.634 times 2.5. So the definite integral will be 686.585. Now this is going to be an under approximation of the actual area that we just found. And that should make sense because we see that this graph is, everything here is below, we have gaps here. Okay, so we know the area of these 4 rectangles will be under the actual area. So the average temperature formula is just 1 over b minus a and then we found the definite integral using approximation, which is 686.585, and divided by 10, we get 68.659 degrees Fahrenheit. Okay, last problem here. Solve the differential equation dy over dx equals y over x. So we separate the variables, take the natural log of both sides because these are both in the form of 1 over u. So natural log of y is equal to natural log of x plus c. We raise both sides with base e. The left side becomes y. The right side, we have e to the c as a constant, so we pull the constant in front. And then we can plug in the ordered pair negative 2, 1 to find the x value. So 1 plugs in for y, negative 2 plugs in for x. Absolute value of negative 2 is positive 2. So c is simply equal to 1/2. So our specific equation is y is equal to 1/2 absolute value of x. However, this graph is going through negative 2, 1. So if we look at the graph here, this graph with positive slope is not going to hit the origin because x cannot be equal to 0. So our domain is simply from negative infinity to 0.